the first thing I'm going to do is I'm going to talk basically on social complexity. I'm going to suggest areas where probably normative behavior could be taking place. And basically, I create a situation which you could, expert of normative behavior, find maybe other examples of use of rules or use of norms in animal society. But I'm going to focus on social complexity overall. So I'm going to start basically by trying to define complexity. Yeah. And so one possibility is that this looks like something rather complex. And then I'm going to have a complex definition of complexity that is the emergence of macroscopic spatio-temporal patterns for systems composed of many elements governed by simple rules, the elements of being non-identical and with different types of interactions. And I want to focus on these three kind of set of elements, especially that is emergence, simple rules, different types of interactions. And that's how often complexity is seen. Okay, so it's if we think about what Christian mentioned early on self-organizing, there is something that emerges from the elements that you have. So I see there are two main ways to see see complexity in general, and one is from the outside. So you see this emergent property. Here you have elaborate, looks like a rather elaborated or rather complex, and now from outside you see the entirety and so on. But you don't perceive necessarily what it looks like the inside. Instead, the other view is from within, is the single individual facing this object and so on, what is. And I feel there are very different, the two perspectives. And that's been in the animal world usually a kind of a confusion by looking only at the first part, but then try to explain the first part with individual characteristics. So the individual need to have some cognition to live in the complexity that is seen from outside, but that the actual individual will never see. And I'm going to bring you to seeing instead from the within to understand. So this is a kind of something very simple in a kind of a diagram of what social complexity could be. So we have now from what I mentioned until now about complexity we add the word social. So the lines are social interactions and the circles and squares are individuals. And these individuals are, as you can see there, they can be either red or green. So we could imagine, but it could be many other things. It could be that the circles are females, the squares are males, the green are younger individuals, the red are older individuals. So here we have basically four classes of individuals. We have young males, young females, adult males, adult females, and the way they interact with one another. Again, we could come up with something else, dominant, subordinate, and so on. So we have a different and then to try to get an idea. So what is seen from outside is basically what the scientists see of this system is the complexity that emerge from the interaction between the group members. So the simple part are the interactions, and the complexity comes from integrating all this interaction in something that is emergent. We basically studying them, collecting them, creating models and so on, something that doesn't actually exist in reality is an abstraction. The view from inside instead is what that particular individual sees. And so what is the complexity for that individual? What is the experience of the individual? And clearly that individual doesn't have to have at all the overall emergent property in view, because that is not important for that individual. So if we contrast the outside and within, I think a good example of that is thinking about the honeybees. The honeybees, all of us will agree that live in some complex societies. There are a lot of individuals. They have a highly cooperative. They have to figure out a way to cooperate, and there's a division of labor. So all things that looks pretty complex. And so if we see them from outside, no doubt, it's a complex system. But for the single individual, what actually has the complexity is rather small in terms of social complexity, because the if we think that they need to do different things with different individuals, now we have early on the right side, the kind of the four possible classes of adult males, adult females, young males, young females, and so on. Here, the B need to have, let's say, if different society have different numbers of castes, but they have four different type of castes, and need to do distinguish the behavior only for four types, nothing else. They will behave with all the same individual, the same caste in a particular way, and all the individuals of the different caste in a different way. And so, although it looks and the emergent property is very complex, for the individual B, possibly is not. What does this link to norms? We are going to get there. So the complexity experienced by each group members is a possible definition of that is really the number of types of differentiated relationship an individual has. And this is the social complexity. That's why it's important to talk about the relationship that you do have. So with a colleague of mine, Gabriele Schino, we put the attention, try to focus the attention on the social complexity from within, and we focus on how individuals experience the structure and the organization of their group. And so in the next slides, I'm going to focus about the structure and our organization of groups and what are the elements important. And to do that, I use frameworks that these authors put forward over the years. So a social structure, we focus on the interactions that individuals have in a group, and from that we can observe, we can collect data from, and then we can infer social relationships, and from the pattern social relationship, we can link it to social structure. I'm going to show you in a moment a little bit more schematic system. So, but the other part, the social organization, instead refers to the group size, the group composition, and the spatial temporal cohesion, that how the groups, how the individuals are more or less cohesive with one another. And that's, I'm going to use the terminology of fusion dynamics, but I will define it in a moment. So the framework that Robert Hines put in the 70s is still a very valid framework to look at social structure, starting from social interaction. So the social structures, the social interactions are the building blocks of the social structure. We can observe the interactions that individuals in the group do, and from the interactions of two individuals, and the patterns, so what kind of interactions they exchange, what is the frequency, what is the temporal patterns of those, we can infer their social relationship. If we do that for all the different pairs of individuals in the group, we have basically a possible description of all the social relationships in the group, and then the pattern of the social relationship in the group give us the social structure. While I think talking about social interactions and social relationship is rather easy to think about anymore, then getting what is the social structure, well, an example is difficult. So I always try to get to the idea of a dominance. And so the social interaction are the aggressive behavior, the submissive behavior. You extrapolate from that the dominance relationship between two individuals, and then between all the pairs of individuals, and then you try to come up with the structure, and the structure is the dominance hierarchy. So a dominance hierarchy is a structure that regulates the behavior of these individuals, and because regulates, I use it on purpose, there is a link to the norms here. So the potential link to the norms is that basically what I show you is not going only down, but goes also up. So we have that the social structure basically constrains the type of social relationship that can be developed in that group. And then for each individual, the type of social relationship that one individual has with another individual constrain somewhat the type of social interaction that will actually interact with. So the first step, basically, we could imagine with an immigrant individual getting to a group that has a particular social structure, and then he has to conform using terms that basically Kristen used early on. So that's, I think, the conformity. It can be the behavioral conformity is basically you need to fit in that particular group. And this is interesting because we mentioned about the Japanese macaques, and macaques is a very good example. I've been in a previous life before the life on spider monkeys. I worked a lot on macaques, and macaques there are many different species, and they have overall a very similar social structure. So they have a strong dominance hierarchy, and they have a matrilineal system because females stay in the group for their entire life, and so they form matrilines with their daughters, their mothers, and so on. So we have several generations within the same group of females, while the males are the one going and coming. So with that type of social structure, you still have a variation across species. And so you have some species that are much more tolerant and some other are much more despotic. So imagine the immigration of an individual, let's say a macaque, without the link of other species, need to adjust, for instance, what is the species. And possibly we have also variation within the species and then the type of adjustment. And so that's why I'm saying, okay, that's a potential, and you're going to see the question mark quite a bit because I'm not sure, but I mean, it could be that there are group norms and then the new individuals or the individual that grow up in that particular group, they need to follow because the social structure of the group, so the group norms, will kind of lead to what type of social relationship it can be developed, and then what are the social interactions that can exchange with one another. Now, going to focus on the social structure and looking at how that actually influences social complexity, as I mentioned early on. So the degree of differentiation between social relationships should be an element on that. Then we can, as I mentioned in the very beginning, when I show you the graph for illustrating social complexity, there could be sex combination, and then we have that you could differentiate all the members in the group as all the potential combination in the group as male-male, male-female, and female-female. So there are three combinations. We can do the same for age, as an adult, young, and adult, and then relative dominance rank, kinship, and so on. But this, I put it the categorical one with sex. We can do a few more categories if we want to, but they are always category. But all the other three, actually, they can be category and continue. Imagine the kinship. We can go with whatever definition of kin we have to be kin and non-kin as a category. But otherwise, we can look at the degree of kinship. And so we could have basically a kind of a continuous possibility of the degree of kinship. And looking at now social complexity, clearly when we have a continuous, for the individuals, the single individual, they need to look at the social landscape is much more complex to deal with something is a continuous variation and categorize in a way how to behave with all the different types than a category. And then this is when I'm talking about one single type, one single classification like kin and non-kin based on kinship. But in fact, if we have multiple factors, so the individual need to take into account the sex combination, the relative age, the relative dominance rank, the kinship, clearly is much more complex. So these are elements. They are the challenges that the individual that is in the social in the group need to deal with, and somehow could be even more complex the life of the single individual facing all the things that they actually what they look like on emergent property. So it doesn't need to be that what I was saying before with the honeybee that look like it's very complex, but for the individual it's not. Yeah, maybe the emergent complexity is similar of the illustration I pointed out, but actually for the individual to actually work and function in society, in the group, could be actually very complex because you need to take into consideration a lot of different elements. And the same if we want to do a kind of a different type of characterization of social relationship instead of some characteristic of the individuals, getting something that comes out of the way they interact with one another, so different components, and we want to have basically independent components of relationship quality There could be the degree of security a relationship has, the degree of value that the relationship has, the degree of compatibility that the relationship has, and so on. So we can come up with all. And there are nice ways to, from social interaction, to come up with this from a statistical point of view and get it. So here you have that could be this one single component. It's basically is the value of the relationship that is important, or we have multiple components. And again, we have higher complexity when there are more components. Another one, and that's easier to link directly to norms, is basically the stability of variation of in social relationship. And let's think about it, one single social relationship. It is stable in a way, it is easy to deal with because it's always the same, it's a variable, it's much more complex. And here we get that ways to get this variation. So the complexity individuals experience in relation to the temporal variation within the social relationship could be that there are predictable developmental changes. So there are changes that are linked to age. And so the young individuals slowly change their type of interaction with older individuals in the group. And so that in a way change the relationship with them. And is a kind of is a variation that is actually following a rather predictable path. Like imagine the mother-infant relationship. You know, clearly there's a development over years, but it's rather predictable the way it will do. And the same for an immigration. It's a rather predictable because the individuals arrive without the knowledge of the individuals in that new group, and they need to have need to know the individual, need to understand the type of characteristic that they have, and then start to develop the new relationship. But it's something rather predictable. It's always the same issue model. But then there are also variation that is based on unpredictable changes. And one good example is a dominance reversal. So two individuals have a clear dominance relationship. One is dominant over the other. And then for some particular event, there is a reversal. Then it's changing the relationship. The one that was subordinate now is dominant. And of course, it's a big change for their own relationship, but it's also something that impacts the rest of the group, of course. So here, if we take the two types of changes, and we're focusing on for high complexity, the unpredictable is a more complex, and is the one that the individuals have to face issues. And what at the level of norms, I think these two changes are interesting, because from the predictable developmental changes, basically the young and immigrants need to adjust to the norms of the group, as we were mentioning early on. But maybe with the unpredictable changes, that there should be a rapid adjustment to the possible new norms. Because now there is a variation of what was, and maybe, you know, if really what is going to change is the most dominant individuals in the group, possibly there need to be some adjustment depending on how that would be placed. So there could be this short-term change that Kristen was mentioning. At the level of the social organization, I was mentioning that I'm going to focus only on this aspect of fission-fusion dynamics. That is the aspect that I've been working the last 20 years by moving from the macaques to the spider monkeys, and what it is. So basically, Hans Kummer suggested that fission-fusion is basically an adjustment of group size to local resource availability with the formation of a temporary formation of smaller subgroups. Basically, for our point of view, is just that basically, instead of having a cohesive group moving in the environment, basically there is formation of subgroups. So the same group could change into subgroup that every now and they meet, and they meet always the same individuals, and they form the larger group. Or there's a higher degree of fission-fusion dynamics where there's a formation of several subgroups of variable size and variable composition, because when the individuals meet, they reshuffle, and the new subgroups are in different subgroups. That's a typical happening in chimpanzees, and the spider monkeys basically do exactly the same. So it's the closest system to chimpanzees, and so that's what I was particularly attracted. But we work with several colleagues for the concept of fission-fusion dynamics, and we came up with basically that any social system could have a different degree of fission-fusion dynamics. So the one they are always moving in a very cohesive way, basically they have a degree of fission-fusion dynamics 0. and then there is kind of a continuous dependence how frequent are the patterns they do it, how variable they are. But for the purpose of this talk, the main point that the fission-fusion dynamics influence the opportunities for other group members to interact with one another. So here we have, and then so because they are in different subgroups. So then, so if they are in the same subgroup, they cannot interact, and when they are in the same subgroup, they can. So it really influences the opportunities. And let's remember this word opportunities. And then they also change the extent to which the social environment changes. So two individuals may behave in one way if there are certain individuals around, and may behave in a different way when there are other individuals around. So the change of subgroup composition creates also a challenge on the way that the individuals behave. Here we can see some of these opportunities. Fission-fusion dynamics influence the opportunity to interact with the same partners. The higher degree of fission-fusion dynamics, there's a lower interaction rates between individuals because they are in different subgroups. And that leads to uncertainty. And that's one theme that I think is important to touch in the context of this symposium. There's higher uncertainty about social relationships. And then instead, if we are looking at the opportunity to interact with different partners, the decision about interaction are affected by partner availability. So although I would like to interact with a particular individual, is not available because it's not in this subgroup, so I need to interact with others. And so this the fission-fusion dynamics also kind of influence how to interact with different type of partners. And there is uncertainty about how to interact with the same partner depending on who else is present. So there are two issues of uncertainty that I want to address here. So there is basically the social uncertainty depends on the temporal variation in subgroup composition. And this is something that we also addressed with some colleagues. And I'm going to show you briefly some empirical data. So these are data on spider monkeys, and they're on a group of spider monkeys, and on the x-axis they are basically the cause of all the individuals in the group, the adults and some individuals in the group that are important, and on the y-axis that is a measure of uncertainty, and that lower values means higher uncertainty. So on the bottom, so these four individuals are the one that have a higher uncertainty, and as you can see, there's quite a big spread of uncertainty. The squares are males, the circles are females, and they are not that different. The squares on the right, they are not much. There's a variation between males and females. Doesn't seem that it's much different. But these four individuals are very interesting. The four with the circle, the lowest value of this index, that is the one that experienced more uncertainty. They are the four more recent immigrant females. So that makes sense. You're an immigrant, you have more uncertainty about everything and so on, and that reflects also. So the higher degree of fission-fusion dynamics gives more uncertainty about interacting depending on variation in subgroup size, and so there is a higher uncertainty because of that. And now we go to one element that there could be way of dealing with this complexity is community complexity. And here is basically that you expect that there should be signals to reduce this uncertainty. And now I'm going to try to push it to the norms. The signals could be norms to reduce, or could be linked to norms to reduce uncertainty. And while I think a lot of you are doing this great effort to study basically the origin of elements of norms looking at the animals, I do the other around to understand and try to link. I look at the humans and it's okay. What do we do when we meet? We greet. Okay, so greetings is basically a convention. It's a signal, it's a convention, and you follow certain rules when you greet. So I think it's a very good example of potential finding norm. And we meet, and when we meet, so when we have been separated and we meet, basically, I think fission-fusion dynamics, we live in a fission-fusion society with a high degree of fission-fusion dynamics. So a lot of things I'm telling you actually applies to our own species. But in spider monkeys, they do the same. They embrace when they meet. And they meet after they've been in several subgroups. Now, the interesting is that, yeah, what is the function of this behavior? And we actually, I think we have better data now on the animals than on humans, you know. And so we actually know that when two subgroups get together, there is let's say, aggression in spider monkey is not very common, but one of the contexts in which aggression occurs is when two subgroups get together, and it occurs between individuals that were in different subgroups. These are animals that belong to the same group, so they are not different groups. But if they embrace, they don't have aggression. So here we have a clear example of a behavior that is a greeting behavior that actually functions to reduce aggression. And so we could speculate that greeting humans could have originated with a similar function, and then, of course, then we may have using a much more. But clearly, greeting removes certain uncertainty also in humans. If you go there and somebody doesn't actually want to greet you, you start to feel a bit uncertain while you greet. Clearly. In a move from communicative complexity to cognitive complexity, there's much more to tell, but I want to focus on one particular example. Here is something that actually Kristen, by chance, mentioned is on the self-regulation. So fission-fusion dynamic influence the extent to which the social environment changes. And at fusion, what happens is that there's a very good idea to have a control of the predominant responses that you expect. The reason is that because the social environment is changing, instead of continuing to do what you were doing with the previous individual, they may have been coming maybe some rivals or the best friends of that individual. So better to wait, assess the situation, and then act. So and the enhancement on inhibition in species with high degree of fission fusion should be possible, and we colleagues, we have been able to show that actually is the case. So there's enhancement on inhibition or inhibitory control in species with higher degree of fission fusion dynamics, and this is linked nicely with norms. If you think about enhanced inhibition, the first step is to adjust to changing the social situation, but actually they could be also adhere to current norms. They feel, well, okay, now with this new subgroup composition, do I need to behave in a different way? Do I need to follow different rules? And these are very kind of temporary rules potentially, because the subgroup composition is actually changing. And I'm going to finish with a couple of conclusions, and I'm not going to have a conclusion on the social complexity, but I'm going to focus on the social complexity, the background of this talk. So when we focus on social complexity from within, from the individual perspective, I show the elements of social structure that influence social complexity, that is the variation, or in general, and for the social organization, looking at fission fusion dynamic, the uncertainty. And I think both of them will have a room for coming up with ideas about studying norms, because the norms increase predictability and reduce uncertainty. And both variation it creates unpredictability. So the increase of predictability is very valuable for the first part, and the reduced uncertainty clearly for the elements for the social organization I mentioned. The next step, and that is my last slide, is on the social structure and social organization. Seeing as a social structure, you have constraints. If you live in a particular group with a particular social structure, there are constraints. In a social organization, you have opportunities. That was the word I mentioned early on to remember. So here we have a situation, the words that you guys often use, and then I add a word that I remember came up quite often in the other workshop that Giuseppe and the colleagues from Cordoba Energy organized last month. That is affordance. And so this, I think the constraints create affordance, the opportunity create affordance. So again, there's room for norms. Yes. So I'll leave you with this, and I thank you for the attention.